Welcome back for more physics solving fun. So in our first question, we have a 25 cm long wrench and the mechanic who exerts a force of 17 newtons at the end of the handle at 37 degrees. We are asked to find the torque and what is the maximum torque he could exert with this force, in what direction. In question A, we know that torque is given by the length of the lever arm times the force. In this case, we have to take into account the angle on how the force is applied, which is 37 degrees. We must always remember that when the angle is rotating in a counterclockwise fashion, the angle is positive. Therefore, we have a positive answer of 2.56 Newton meters. In question B, the torque will be at maximum when the force is perpendicular to the position of the vector. That is, when the angle is 90 degrees. Since R and F are constant, we would just need to change sine 37 to sine 90. See how the value changes when the angle is turning clockwise and counterclockwise? When we have a positive answer, it means that we have an angle that is rotating in a counterclockwise fashion, and a negative if the angle is rotating clockwise. In question number 2, we have a flywheel of an engine that has a moment of inertia of 1.60 kg square. We are asked to find what is the constant torque required to bring it up to an angular speed of 400 rev per minute in 8 seconds starting from rest. The formula of total torque we're gonna use in this question is I alpha. We still need to find alpha. We can do this by the following steps. In solving an equation, we first need to find our variables and the respective values. After doing that, we need to make sure that our units are the same with the formula we're about to use. In this case, we first have to convert 400 rev per minute to rad per second. We can do this by multiplying 2 pi rad over rev and 1 minute over 60, because we all know that 2 pi rad is equals to 1 revolution, and in 1 minute there's 60 seconds. Now we can sub the values to our formula. Alpha is equals to final angular velocity minus initial angular velocity over time final and time initial. And we would get an answer of 5.24 rad per second square clockwise. And there you have it. We would just need to plug in our values to our first equation. That would give us an answer of 8.38 Newton meter torque required. In question number 3, we have a solid uniform sphere with mass of 225 grams and a diameter of 3 cm. It is spinning on a frictionless axle on its center, but at one point, it is scraping against a metal, resulting in a frictional force of 0.02 newtons. We are asked to find its angular acceleration and how long will it take to decrease its rotational speed by 22.5 rad per second. Using the same formula we used last question for torque, which is total torque is equals to I times alpha. This time, we would just need to isolate alpha, resulting to torque over I. Now, from our first question, we know that torque is equals to force times the lever arm. Our lever arm would be the radius of a sphere, which is 0.015 meter. Now, the moment of inertia of a uniform sphere is equals to 2 over 5 times mass times lever arm squared. Now, plugging in our values to our formula, we will get an answer of negative 14.8 rad per second square. We have a negative answer because the sphere is decelerating because of the frictional force against it. In part B, we are given the change of angular velocity, which is negative 22.5 rad per second. We can use the formula final angular velocity is equals to the initial angular velocity plus alpha t, which is time. By isolating time, we would get time is equals to change of angular velocity over alpha. We have already computed alpha from part A, which is negative 14.8 rad per second square. Plugging into our formula, we would get the answer of 1.52 seconds for the sphere to decrease its angular velocity to 22.5 rad per second. That's all for today. Thank you so much for listening. Hope I was able to help. Tune in for more physics solving fun. Now don't forget to like and subscribe.